Welcome folks. So in this video we'll work another example of a modeling problem. In this scenario we have a river. We're going to build around the river, or not around it, we're going to build alongside of it, and we're going to build a corral by building 3 of the sides of it. The river will be the 4th side essentially. We do know also that we have a total of 900 feet of fencing. So in traditional Mr. Chang fashion, we're going to start off by highlighting our important information. Let's see, we have 900 feet of fencing. That makes sense. We're also only putting up 3 sides, so that's important to remember. And we also want to figure out what our variables are. So A will be the area of the corral, and X is going to be the length of the fencing for these particular sides, the sides perpendicular to the river. So let's actually draw this picture. So here's the river here, right there. Our fencing then, I'll draw that in green. It's going to be like this. It's going to be rectangular. And so the sides perpendicular to the river, which would be these two, have a length of x. Okay, so we need to find then, for question A here, the equation or some equation representing the 3rd side. So I'm just going to call this 3rd side, I'll call it C. I think in the text it calls it, I think it calls it Y, but I'll just call it C for right now instead. Okay, so if that's the case, then, well, we do know that we only have a total of 900 feet. And so all our fencing is going to be put towards this fence. So that must mean that 900 is equal to 2x, or x plus c. Hopefully that makes a little bit of sense, because I think it does. Because again, we're not building that 4th side or along the river here. We're not putting that there because, hey, the river is going to keep our cows or whatever inside the area. If that's the case, then we can just rearrange this equation to say that 3rd side is just going to be 900 minus 2x, and that would be in feet, whatever that is. Okay, so the length of the 3rd side depends on whatever x is. That makes sense. Okay, so then let's find an equation for A, and let me just resize this and drag this around. By the way, I did not work this problem out ahead of time, so I have no idea what the answer is going to be. I actually usually don't work the problem out ahead of time, so that might have actually been evident already. Anywho, so let's write an equation then for A of x. A of x, well, we know it's a rectangle, and A is the area. So again, it should be A of x because A is a function of x. Whatever x is, A depends on it. Okay, so that would mean that the area, well, that's going to be length times width. So that would have to be c times x for this rectangle. But remember, we know that c can be written in terms of x, and also we want our only input to be x. So I'm going to have to just do a little bit of substituting, and we'll have 900 minus 2x, that's a minus, times x, which, when we work it out, should be 900x minus 2x squared. Alrighty. Moving on. I think this is going pretty smoothly so far. Moving on. We want to find A of 100 and A of 300. I'm also going to just draw a picture here just to represent what we're actually doing. And so A of 100, well, I'll draw a picture afterwards. Simply just plug in x equals 100. So that'll be 900 times 100 minus 2 times 100 squared. I could bust out the calculator, but we don't really need to. So let's see, 9 times 1 would be 9, and then 4 zeros. 3, 4. Minus, let's see, 2 times 100 squared. Well, that'd be 1 and 4 zeros again. So that'd be 90,000 minus 20,000. So that would just be 70,000 square feet. Let's not forget our units, square feet. So in this picture then, this is what this would look like. We have our river here. Our corral then has a length of, I don't know really what this is going to look like, 100 feet there. And then 100 feet here. I guess this would have to be then 700. And then the area inside would be 70,000. If you want to do the same thing with A of 300, A of 300, that'd just be, well, 900 times 300 minus 2 times 300 squared. That's going to be 270,000, 4 zeros, minus 2 times 90,000. And let's see, that'll be, I think, 270 minus 180. So I think that'll actually be 90,000 square feet. And so this tells us that, hey, if I set up this corral, oh, I kind of switched the colors here. Let's change that. Oop. That if I extend the sides here a little bit, so this will be now 300, and this would actually be 300 on this side as well, so this actually would be square. This is actually going to have an area of 90,000 square feet. Okay, here's the question. What would be the greatest possible area? Okay, here's an interesting problem because we have no way of kind of knowing that, at least initially. But think about this. Remember, the area is represented by this quadratic equation right here. And so, if I extend this, let's just remind us that A is a function of x, which has the equation, I'm going to rearrange the equation like so. Negative 2x squared plus 900x. Okay, the reason I did this is because now it's really clear to see that our A value is negative 2. What's the point of doing that? Well, remember that when I have an equation in standard form, that standard form doesn't really tell you much. But what it does tell you is it can tell you the y-intercept. In this case, it's 0. It also tells you the orientation, though. And so because A is negative, we know that this is a downward-facing parabola, a frowny-face parabola. Like so. So the question is, where would be the greatest possible area? Again, the greatest possible area is the dependent variable here. And again, this is x, the dimensions of, the length of that one side. The maximum possible area is going to happen at the vertex right here, the very, very top of that parabola. And so we can actually figure out what the vertex is, because remember, the x-coordinate of the vertex is always at negative b over 2a. In this case, that's going to be, let's see, negative 900, because that 9 is our b value. Negative 900 divided by 2 times a, which is negative 2. That's going to happen at, let's see, 900 over 4, which I believe is 225. Okay, so that would tell us again, that is just x, the x-coordinate of the vertex. And to find the area then, we would just need to plug that x value in. And so that would mean A of 225. Ooh, this is going to be a little bit more annoying to actually solve. Actually, I'm not going to do that because we don't need to. Reason being is I can actually draw this picture now. Let's just draw this so we know here's the river here once again. And we know that this thing is going to have, this rectangle is have a side length of 225, and something. So on top, remember, we only have 900 feet to play with. We've already used, let's see, 225 times 2 is 450. So this piece is going to be 900 minus 450, which is 450. Sorry about that. I'm still getting used to this, so I don't know why it's still skipping, unfortunately. That's a 450. Boom. Okie dokie. So that means our rectangle here is just 450 by 225. And so my area is going to be equal to that, which is still annoying to deal with, unfortunately. So I'm just gonna bust out my handy dandy calculator here. 450 times 225. That's gonna give us an area of 101,250 square feet. Don't forget those units, folks. Boom. We also want to figure out now, when would you have a 0 area? And I want to take a stab at this one from a, well, one, we can do it purely mathematically, but also from a little bit of a common sense way of thinking. And so, what value of x would make the area 0? Well, if I set this equation, a of x, which equals negative 2x squared plus 900x equal to 0, well, we can just solve it using the quadratic formula if we wanted to. But why go through all that trouble? Let's not make our lives too complicated. Let's just solve it by factoring. Because I can factor out an x here. I'll get negative 2x plus 900 equals 0. And I can see already, using my zero product property, or our ZPP, that either x has to equal 0, or this piece equals 0. If that's the case, then, well, 900 has to equal 2x equal, sorry. It's okay, we chillin'. 2x here equals 2x. I just moved the negative 2x to the other side. Divide by 2, we're going to get x equals 450. Now, notice, we actually probably didn't even need to do that, because with a little bit of logic, we could have already figured that out, that if x equals 0, then of course this corral is not going to have any area because, well, there is no side length there. Okay, so we already knew that this graph right here contains 0. And since we already know that the vertex happens at 225 there, remember, because a parabola is symmetric, if the distance from the vertex to one x-intercept is 225, then the distance from x to the from the vertex to the other x-intercept is also going to be 225, right? And so 225 plus 225 is going to get you to 450 anyway. 450, right? So that should definitely make sense. What does this actually look like then? Well, in the case where x equals 0, that would be this scenario, where there's your river, and you're, well, you don't have any, you don't have anything. And then if you had the other scenario, where x equals 450, here's the river, and then your pen is just gonna look like this. 450 there, 450, and then 0 horizontally. All right, those are just lines, so they don't actually have any area. And sketch the graph over a reasonable domain. So we kind of have already done that, but let's just do it right here. Again, so we have a of x right here, our parabola again. So we already know that this parabola looks something like this. Oh man, I don't like drawing on this thing. Like so, that's not bad. But remember, it doesn't make sense to make the fencing with a negative x length over here, so that shouldn't be there. And also over here, we can't actually make that x side length any greater than 450, because otherwise we don't actually have a pen, or a corral rather. So we're going to want to change this graph just a little bit. Eraser. And actually alter our domain to only be from 0 to 450 right there. So let's just erase that like so. Okay, so our domain should only be from 0, 450. Alrighty? That was a really fun problem. I hope you enjoyed it as much as I did. Alrighty? And stay spicy, folks. Stay calm. I'll see you in the next one.